if we take a step back, then it turns out that in the context of processing and analysis, the text is not really convenient data. Because if you consider text as a sequence of words, then we have two kind of important characteristics. Firstly, we have a variable length, which is obvious because sentences, of course, have different lengths. But also here we deal with nominal data, which simply means that words are basically just labels. So we can say if two words are the same or not, but it doesn't really make sense to add or subtract words or multiply words. And the problem here is that many to most common techniques or algorithms have two requirements. They require some kind of standardized input, which particularly means that the input is of fixed length. And most algorithms also require that the input is numerical, so that these algorithms can in some shape or form add, multiply, scale, or directly compare their input. So this means essentially that most of the important techniques do not directly work on raw text. And this, for example, includes also logistic regression. So what we need is some suitable representation of a text document that converts text of arbitrary length into some kind of representation that is both numerical and standardized, particularly again, fixed length. And this process to get there, meaning to convert our text document into some kind of suitable representation, is called feature extraction. Which essentially means that we have a text document and we convert it generally in a vector. And a vector is basically a construct of equal size with numerical values. And these numerical values, these vector elements, obviously have some kind of relationship to the text to preserve as much meaning as possible. So these numerical values need to preserve interesting characteristics. Of our text. And this is of course not trivial. So if you look here on the right hand side as example, so here we have a news article, and what we want is some kind of numerical vector of a fixed size. But of course the question is, how do we get there? How do we find these values that they preserve as many interesting features of the original text as possible? A manual approach for feature extraction is the design of handcrafted features, where we as NLP practitioners decide which kind of numerical features we want to extract from our text documents. So here in this example, we assume we want to build a sentiment analysis system, and we could consider features like the length of the text, we consider the number of positive and negative emoticons, or the number of words associated with a positive and negative mood. So for example, we would know that words like happy, great, are typically more associated with something positive, and something negative might be bad, boring, and so on. So we have to decide which kind of feature we want to extract, and then after we have decided, we can apply this on our text documents. In this case, for example, we have two movie reviews, where arguably the first one is negative and the second one is positive. And here you can, for example, see that when we look at the number of negative emoticons, For example, this one stems from this negative emoticon. Similarly, if you look at negative words, you can make the argument that hated and boring are negative words, so we count them up here. But we also see some positive words like brilliant and beautiful, but we only see those words in the second review. And this is, for example, where this 2 comes from. So for each kind of feature that we decide we want to extract, we apply it on our text documents to get these numerical values. And now we have kind of vectorized our input documents.